So once again, the good news for 84 is you know how to do all these. Because if I give you 3/4 is equal to x over 12, you would tell me you need to do what here? Cross multiply. 3 times 12 is 36, divided by 4 gets us 9. Therefore, solve part A. 30 over x squared minus 25 is equal to 3 over x minus 5. Hint, parentheses may be helpful. At this point, I think we all know that we're working with quadratic, so we just can't simply solve for x, but instead we'll have to get it set equal to 0. I'm going to subtract 30x and add 150 to both sides. And 150 and 75. There it is. Can we factor this thing? Well, before we try to factor, do we have a greatest common factor? Yep. What are we left with? 25? And the only thing with these is, notice we had a variable in the denominator. So we came up or derived with x is going to equal 5. But if I plug it in, are we okay? What happens? First thing I notice is 5 minus 5 is 0. It just so happens to be if I plug it in there, it also is 0. But I don't care if it did it over here. I found it to be 0 over there in one of the fractions. Therefore, this 5 is extraneous. Therefore, do we have any real solutions? No, we do not. So anytime you work with rational expressions, you have to be leery of, okay, does this thing make it undefined? Go ahead and start on problem B. Just note, I'm going to move these two over to the left because I want that x squared to be positive. So subtract 5x to both sides, I get positive 4x. Can we factor? I believe so. And once again, what's the one thing we probably need to check for extraneous solutions? 5 for sure is going to be extraneous because 5 minus 5 is 0. So, sorry, not going to happen. Are we okay with negative 9? Yeah, we can get a negative for a denominator. There's nothing wrong with that.
Awesome.
I'm going to change this number on you. This is not a 4. This is 10x. 10x over x minus 9 is equal to 15. We don't have two true rational numbers. You know, 15 is rational, but we don't view it that way. But we could write it this way. And that's my advice. Now you know what you need to do for sure. $145? No.
135.
141?
135.
I'll get it right. Yeah. 135. I need to subtract 15, not 5. Do we have an exponent of 2 here? And the answer is no, therefore you can just use your regular algebra skills here for this one. So move the, we can move the 15x over, that's fine. Subtract 15 to both sides to get negative 5x. X value that we're coming up with, 27. We could check it if we want to. It's definitely not going to make it extraneous, but if we plugged it in, it would work out for us. Last one that I have for you is part B. 8 over x plus 2 is equal to 2. A couple of different ways you could go about solving this one. You could subtract the 2 to both sides to get 8 over x is equal to 0. But then you'd have to figure out how to get rid of that 8. And what would you have to do? You'd actually have to cross multiply because you can't just simply divide by 8 because you still have that x in the denominator. See what I'm saying? If we multiply both sides by 1/8, you know, that's great. Yeah, those cancel. But I still have 1 over x is equal to 0. Okay? So, what do? Well, I don't like denominators, and you've been taught about halfway through how to get rid of those denominators. We multiply by that least common multiple of the denominators, correct? So what do we want to multiply this thing by? Yeah, you just want to multiply both sides by x. It sounds messy, but it's actually going to clean it up quite a bit for us. Because my x's will cancel here, leaving me with 8. X times 2 is just 2x, and 2x. And there's a reason why this is not coming out for us because I have a typo here. Let's change that 2 to an x.
x squared.
Now we'll actually come up with an answer as opposed to no solutions. I'm going to subtract 2x and subtract 8 to both sides. Are we okay with this? And it works out that yes, we're fine. The only denominator was x itself, so it could be -2, and it could also be 4.